So hi everybody, in this video we'll go through the second method of conversion of aldohexoses to aldopentoses. So basically this is a step down mechanism, step down method. So where a 6 carbon chain has been reduced to 5 carbon chain. So pentose is 5, hexose is 6. So this method is the second method here is Ruff degradation. So first step, your aldose is oxidized by bromine water to corresponding aldonic acid. So if I take glucose, D-glucose, so CHO, so this is your D-glucose. When you react it with bromine water, Br2, H2O. So essentially what happens? Oxidation takes place. So oxidation of what? Oxidation of this aldehyde to your carboxylic acid. See, this mechanism is there, so I don't want to get into too much details. If you need, you can message me. So CH2. Now this is reacted with calcium carbonate, CaCO3, aqueous. So calcium carbonate acts as a base. Now you might ask, sir, how calcium carbonate is supposed to be a salt? How does it act as a base? So what happens is, when CaCO3 in aqueous breaks down to, it's a basic salt. Okay, it's a salt, no doubt, but it's a basic salt. It breaks down to COH twice plus carbonic acid, H2CO3, and now this base, the OH minus from here, takes away the acidic proton, and what you get is your anion. So you will get minus, everything else remains the same, OH, 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 H, OH, H, CH, H. Now what I'll do is, simply I'll write this as R. Okay, so you can substitute this as R. Okay, so this, now you react it with Fenton's reagent. So Fenton's reagent is a solution of hydrogen peroxide. I'll just write hence fusion is a solution of hydrogen peroxide and an iron catalyst. Typically, it is going to be your iron sulfate FeSO4. Okay, so what this happens, what the hydrogen peroxide and FeSO4 does is, so FeSO4 is present as Fe2 plus, and your H2O2, which is, it breaks to by radical mechanism, it gives you OH radical plus. Now what happens, so two of these plus Fe2 plus, right? Now one of the radical will oxidize this Fe2 plus to Fe3 plus and itself becomes hydroxide ion. So you have a OH radical, you have hydroxide ion, you have Fe3 plus. Okay. So what can this OH radical do? So OH radical again reacts here. So follow the step carefully. No, this is not. It is. It's already in its negative charge. This is there. Now what can happen is this OH radical can break this bond, cleave this bond to homolytic cleavage and give you okay. Now what is this? This is your negative charge, right? So negative charge also essentially consists of two electrons. So one of the electrons is going to reduce your Fe3 plus to Fe2 plus, and what will happen is your another okay, this is formed, radical is formed. So next step is your this radical falls back, this bond, one of the electron falls back, one falls back here and this one falls back here. So what has happened is your HC plus your carbon dioxide gas is eliminated. So this gas is eliminated, so this is your driving force, formation of gas. Why is this a driving force? Because when gas is released, what will happen? Entropy increases. So this increase of entropy is the driving force. And meanwhile, what you have done, you have got this as a, you have got an aldehyde. So now let me substitute your R from here. So what is R? 1, 2, 3 CH2. Okay. So I'll just copy, cut, paste this one. And so your R, let me write it. I'll write with this HCO. Okay. H, H, OH, H, OH, H, CH2, H. So this, what you have done, how many carbons are there? 1, 2, 3, 4, 5. So this is your Aldopentose. So you have come down from a Aldohexose to an Aldopentose. So this was your chain shortening mechanism. So Ruff degradation. So in chain lengthening, you studied Kiliani-Fischer synthesis. In chain shortening, we have two degradation methods. One is Wolff degradation and Ruff degradation. So thank you.